Welcome to EMR Physics. I am Raju, NCERT 10th Science. We are solving the numerical problems given in Chapter 10, the human eye and the colorful world. In this video, we are going to see how to solve the book back numerical problem 6. The problem is, the far point of a myopic person is 80 cm in front of the eye. What is the nature and power of the lens required to correct the problem? In this problem, it is given that far point of a myopic person is 80 cm. What is asked? We have to find the nature and power of the lens required. Now let us see how to solve this problem. For a normal eye, the near point is 25 cm and the far point is infinity. If a person is suffering with myopia, then he can clearly see the nearby objects. He cannot see the far objects clearly. Suppose if the object is at infinity, then the eye with myopic vision will form the image before the retina. Therefore, he cannot see the object clearly. If the object is brought closer, then the image will be formed on the retina. He can see the object clearly. To do this, a concave lens can be used. If the object is at infinity, then the concave lens will form the image at closer distance. The eye can see the image clearly. In our problem, it is given that far point is 80 cm, not infinity. So, we have to use a suitable concave lens. The concave lens has to form the image at 80 cm for the object which is at infinity. Now we have to find what concave lens we have to use. That is, we have to find what is the power of the concave lens. Now let us do the calculation. So as we have discussed, a concave lens can be used to correct the myopia. Concave lens can be used to correct the myopia. Now what we have to find? We have to find the power of the lens used. So this is the answer for the first question. The nature of the lens is concave lens. Next, what we have to find? We have to find the power of the lens. In this problem, it is given that far point is 80 cm. That is, if the object is at infinity, image has to be formed at 80 cm by the concave lens. If the object is at infinity, then the image has to be formed at 80 cm in front of the lens. So this is the object distance. Object distance is infinity. Image has to be formed at 80 cm. Therefore, the image distance is 80 cm. Since the image has to be formed in front of the lens, it is negative. What we have to find? We have to find the power. So first let us find the focal length. If we know the focal length, then we can find the power. To find the focal length, we can use the lens formula. The lens formula is 1 by f is equal to 1 by v minus 1 by u. Here u is the object distance, v is the image distance. We know these two values. Therefore, we can find the value of f. 1 by f is equal to 1 divided by, what is the image distance? It is minus 80. It is in centimeter. Minus 1 divided by, the object is also in front of the lens. Therefore, it is minus infinity. So this is equal to minus 1 by 80 and this will become 0. 1 by infinity is 0. Therefore, 1 by f is equal to minus 1 by 80. If we take the reciprocal, we will get f is equal to minus 80. We are taking reciprocal on both sides. So, we will get f is equal to minus 80. V is in centimeter. Therefore, this will be in centimeter. The focal length of the concave lens is equal to minus 80 centimeter. Now we have to find the power of the lens. Power of the lens is given by P is equal to 1 divided by F. Power of the lens P is equal to 1 divided by focal length. So this is equal to minus 1 divided by 80. If we convert the centimeter to meter, then we will get the power in diopter. So this is equal to minus 80 into 10 to the power minus 2 meter. Therefore here into 10 to the power minus 2. This is equal to, the 10 to the power minus 2 will go to the numerator as 10 to the power plus 2 divided by 80. 10 to the power plus 2 is nothing but 100. So minus 100 divided by 80. So if we do the calculation, we will get this is equal to minus 1.25. Since we have converted the focal length to SI unit meter, we will get the power in diopter. So P is equal to minus 1.25 diopter. So this is the answer for the given problem. If you find this video is useful, please subscribe the channel, share it to your friends. Thank you for watching this video.